Hi everyone, welcome to another interesting lesson. In today's lesson, we want to solve this nice expression, this interesting expression. We want to find solution to the value of n without using the calculator and using the approach of algebra, pure algebra with an Olympiad genius-like approach. I will show you not one but three powerful methods, and you will see how all of those methods are secretly given the same results. Now let's dive in. Solution. We need to find the value of n. From our question, we have 6 to the power of n equal to 54. So we are going to be using some logical approach and a bit of Olympiad tricks. First, take the log of this expression of both sides. We have log 6 to the power of n equal to log 54. Now we can simplify this 54 as log 6 to the power of n equal to log 54 written as 6 multiplied by 9. Now we can bring in first the power n down to the base. We have n log 6 equal to, and considering the log identity, if we have a multiplication form of log expression of this type, it's going to give us an addition expression. So, and this become log 6 plus log 9. So we can now divide both sides by log 6. So we have divide by log 6 from the left hand side, and the right hand side divide by log 6. So now here log 6, we cancel out log 6, then we are left with n at the left hand side, and that will be equal to log 6 divided by log 6 plus log 9 divided by log 6. So here this can be written as n equal to log 6 to the base of 6 plus, simplifying this 9, we have log 3 to the power of 2 base 6. Then we can move these two power, we can move this power down to the base. Then we have n to be equal to log 6 base 6 plus 2 log 3 base 6. But we know that if we have this kind of expression, it will be given as 1. That is, log of base a is equal to 1. So given this expression, we have that log 6 base 6 will be equal to 1. So we have n to be equal to 1 plus 2 log 3 base 6. This is our value of n. Now we use another approach, a clever approach, which is going to be similar to this. That is using the algebraic variant approach. From this algebraic variant, we are going to use this value of n to approach this algebraic variant and put it in a more similar form as of this n that we have gotten earlier here. So from our value of n here, we already know that our n is equal to 1 plus 2 log of 3 base 6. Okay, now what we do is we change the base of the logarithm so that the number looks simpler. That is, we'll be changing the base to 3 instead of base 6. So step 1 from this level is that we have, using the reciprocal rule of log, if we have log b base a, we can write the reciprocal as 1 over log a base b. So considering this, we are going to apply this. So we are going to apply this to this part of the expression. So this part of the expression will now be written as log 3 base 6 equal to 1 over log 6 base 3. Now from here, we know that 6 is equal to 3 times 2. Then this part of this expression can now be simplified using this. So we can now write this as log 6 base 3 is now written as log base 3 into bracket 3 multiplied by 2. So over here, from our log identity, which implies log a b multiplied together, is written as log a plus log b. So we now put this in this form, and that gives us log 6 base 3 will now be written as log base 3 plus log 2 base 3. But log 3 base 3 will be equal to 1. So this expression now becomes log 6 base 3 will be equal to 1 plus log 2 base 3. Substituting this into what we have over here. Okay, the next expression now becomes log 3 base 6 can now be written as 1 over 1 plus log 2 base 3. So since our log 3 base 6 equal to this, and we have our log 3 base 6 in our value of n over here, then we now substitute this into that value. Then from our n, we have 1 plus 2 log 3 base 6. So given that this is log 3 base 6, which is equal to this, we now put it here. We now have that to be equal to 1 plus 2 into bracket 1 over 1 plus log 2 base 3 into bracket. So we can multiply these two with the brackets. We now have that to be equal to 1 plus 2 over 1 plus log 2 base 3. And this value of n over here is a similar value of n to the previous value of n over here. Okay, this is the main form of value of n, while this is the algebraic variant type of value of n. And this can also be expressed in a singular form of n. Considering this value of n, this variant type, then we can rewrite this as, if we have n will now be equal to 1 plus 2 over 1 plus log 2 base 3. So if we simplify this, we are going to have n to be equal to 1 plus log 2 base 3 plus 2 everything over 1 plus log 2 base 3. So but we can add this and this together, 1 plus 2, and that gives us 3 plus log 2 base 3 over 1 plus log 2 base 3. And this is another value of n. This is another similar value of n, which is refers to as the single fraction form of it. So they are all similar. They are all similar value of n, and they are equal to each other. Having gotten all this value of n, so we can label each as, from the first one we can label this n1, then the second one we can label this n2, then for the last one we can label this n3. And the next step is to show you the proof of how this value of n1, n2 and n3 are equal to each other. Now I'll be showing you how algebraic variant is equal to the main form, that is n equal to 1 plus 2 log 3 base 6, which is equal to the variant form of it, and that is 1 plus 2 over 1 plus log 2 base of 3. So we want to show how this is equal to this, so by change of base. Now first thing we need to do over here is to have this log base log 3 base 6, which is equal to 1 over log base 3 6, which we have earlier. But log 6 base 3 is equal to log 2 log 3 multiplied by 2 base of 3. Now here we can now write this as log base 3 plus log 2 base 3. So write this in form of this. Now from here this is equal to 1. So we now have 1 equal to log 2 base 3. And this we are writing is, and this we are proving is equal to log 6 base of 3. So our log 3 base of 6 is now equal to 1 over 1 plus log 2 base 3. Now from here we understand that from the main form we have n to be equal to 1 plus 2 log 3 base 6. This is our main value of n. previously. So we are going to put this value into this part. So we now have n to be 1 plus 2, then into bracket 1 over 1 plus log 2 base 3, close the bracket. So we multiply these two with the bracket. We now have 1 plus 2 all over 1 plus log 2 base of 3. So this is the proof that the main form of n value is equal to the algebraic variant. Proof now is to show you the single form fraction is also equal to the algebraic variant. Now, starting from n equal to 1 plus 2 over 1 plus log 2 base of 3. Starting from this part, we can have, let's say, let a, capital A, equal to 1 plus log 2 base of 3. So here, what we need to do is to say n is equal to 1 plus 2 over a. And this is equal to, if we simplify this, we have a plus 2 over a, then over a. And we can put this as a plus 2 over a. So here we replace the value of a back into the expression. So what we define as a, we replace it back into this part. So we now have n, which is n equal to 1 plus log 2 base of 3 plus 2. Okay, this is our a, which is this, and plus 2 over 1 plus log 2 base of 3. So if we had this 1 plus 2, we have n to be equal to 3 plus log 2 base of 3 over 1 plus log 2 base of 3. So this is the form of the single fraction. This is the form of the single fraction of n. So which prove the algebraic variant is also equal to the single form fraction. Now it's time to show the shortcut method. So from our earlier question, 6 to the power of n equal to 54. Comparing 54 with a nearby power of 6, we know that 6 to the power of 1 is given by 6. 6 to the power of 2 is given by 36. 6 to the power of 3 is given by 216, which means that the value of n is in between 2 and 3. It means that 54 is between 36 and 216. Then n is between 2 and 3. Now let's rewrite 54 as a multiple of 6. Okay, let's rewrite 54 as a multiple of 6. Then we can say 54 is equal to 36 multiplied by 54 over 36. Here, this part can be simplified as 36 multiplied by 3 over 2. If we simplify this, we have this. And this is also written as 6 to the power of 2 multiplied by this in a decimal form is given as 1.5. So don't forget, we are equating this to be 54. So from our earlier question, which is 6 to the power of n equal to 54. So we replace this with this, and we have 6 to the power of n equal to 6 to the power of 2 multiplied by 1.5. Then, if we divide both sides by 6 to the power of 2, divide by 6 to the power of 2, this will go with this, and we are left with 6 to the power of n over 6 to the power of 2, which is equal to 1.5. Now, using the exponent rule, we can write this as 6 to the power of n subtract 2 equal to 1.5. So if we take the log of this expression, we have log of 6 to the power of n minus 2 equal to log of 1.5. Now we can bring this power down to the base. We have n minus 2 log of 6 equal to log of 1.5. Now this becomes n minus 2 equal to log 1.5 over log 6 if we divide both sides by log 6. So we have this. If we add 2 to both sides, we now have n to be equal to 2 plus, putting this in base 6, we now have log 1.5 to the base of 6. So we convert this 1.5 to fraction. So from our earlier step, where we have 3 over 2 as 1.5, so we now replace this 1.5 with 3 over 2 in this step. So n now will become n equal to 2 plus log base 6 3 over 2. Using our log identity, n will now become n equal to 2 plus, from this side we can now have log base 6 3 minus log base 6 2. This will now be our value of n using the shortcut method. But we might be wondering, when we say earlier that our n is equal to n equal to 1 plus 2 log 3 base 6. This is what we told us earlier. Yes, they are both the same, and they can be proved that this is equal to this and this is equal to this as well. So let's demonstrate how this is equal to this. Okay, now from here we have that our n equal to 2 plus log 3 base 6 minus log 2 base 6. So we can rewrite this back in the form of 2 plus log base 6 3 over 2. Now from here we can rewrite this 2 as 1 plus 1, and we know that 1 plus 1 is equal to 2. Then we have plus log base 6 3 over 2. Now from here, let's put bracket here and over here. Now we have this to be equal to 1 plus 1 plus what we have in this bracket. And considering this one, we can replace this with log 6 base of 6 into this part. So the next step becomes log 6 base of 6 plus this expression log 3 over 2 base of 6. Now using the log identity, this can become multiplication. Then we have 1 plus log base 6 multiplied by this as well, 3 over 2 into bracket, and that's equal to n. So 2 here 1, 2 here 3. Okay, so n now becomes 1 plus log base 6 into bracket 3 multiplied by 3. So this becomes 1 plus log base 6 9. We express this 9 as n equal to 1 plus log base 6 3 to the power of 2. We bring these 2 down to the base. We have n equal to 1 plus 2 log 3 base of 6. And this is the proof. We can do the reverse version of this as well by proving this back to what we have earlier. So if we want to do that as well, we can also say from this value of n, we can have n to be equal to this n will now be log base 6 n will now be equal to log base 6 plus 2 log 3 base of 6. Now we move this back to the power. We have n to be equal to log 6 base of 6 plus log 3 to the power of 2 base of 6. Now here we can combine these two together as n equal to log base 6 into bracket 6 multiplied by 3 to the power of 2, and this is equal to n, which is equal to log base 6. If we multiply this will give us 54. And here we can simplify this 54 can be written as equal to 6 to the power of 2 multiplied by 3 then over 2, and this is written as 6 to the power of 2 36 multiplied by 3 over 2, and this is equal to, if we multiply this, we have 108 over 2. So this means I haven't simplified 54 as this expression. So let's take this. Then we have n to be equal to log base 6, log base 6, 6 to the power of 2 multiplied by 3 over 2 into brackets. So we can split this using the log identity as equal to log base 6, 6 to the power of 2 plus, because of this multiplication, and this will become plus, log 3 base of 6, then minus, because of the division, then we have minus log base 6 2. So from here, this come down to the base, this power come down to the base. We have that to be equal to 2 log base 6 6 plus log 3 base of 6 minus log 2 base of 6. So this log 6 base of 6 becomes 1. So we now have 2 here, and that is equal to 2 plus log 3 base of 6 minus log 2 base of 6. And that is the proof of the reverse of n using the shortcut method. Now let's verify our value of n if it satisfies our previous expression, which is 6 to the power of n equal to 54. So we are going to use our earlier value of n to verify this expression, and that value is n equal to 1 plus 2 log 3 base of 6. So we use this value to verify our value of n, our expression, if the left hand side is equal to the right hand side. So we use this value of n to verify our expression if the left hand side is equal to the right hand side. Substituting this value to the expression, we have 6 to the power of 1 plus 2 log 3 base of 6, is that equal to 54. Then we have 6 to the power of 1 multiplied by 6 to the power of 2 log 3 base of 6, is that equal to 54. Now 6 to the power of 1 equal to 6 multiplied by, moving this 2 back to the power of 3, we have 6 to the power of log 3 base of 6. So 6 to the power of log 3 to the power of 2, then base of 6. Would that be equal to 54? So considering our identity, which implies a base a to the power of log base a b is equal to b. So over here, our b here in this case is 3 to the power of 2. So we now have our next step to be 6 multiplied by 3 to the power of 2, is that equal to 54. So if we multiply 6 by 3 to the power of 2, which is 9, that will be equal to 54, which is equal to 54. And this proves the left hand side LHS is equal to RHS, the right hand side. Thanks for watching. I will leave you with a test to go on your own and sit down and verify it. Use the other value of n which we got earlier to verify this expression on your own, and comment below your experience and how you did it and how you get the right hand side to be equal to the left hand side. So let me remind you again, you can use this value to verify it, and you can use other value of n which you got earlier to verify that as well. The variant and the main form, this is the main form that we have used to verify. So you can use the variant form and the singular fraction to verify it. So comment below your experience. Thanks for watching. If you enjoyed this video, please subscribe to this channel, like the video, and share it to your loved ones. And we'll meet in another interesting lesson. Bye for now. Thanks for watching.